Hello friends, welcome back. Today we'll be learning about progressions and series. So what exactly is a sequence? All of these are synonyms. They mean almost the same thing. There is a very little difference. But today, let's first start with a sequence. What exactly is a sequence? So sequence is any set of terms in a definite order, right? Now the definite order will be following a rule so that you can obtain the next and the next term. All the successive terms can be obtained, right? So sequence is a set of terms in a definite order. Right. So suppose we have a sequence which has suppose 8 terms. Now because it is sequence, we know the rule, so we can find out the 9th term. Similarly, we can find out the 10th term. We can also find out any arbitrary term directly, right? Because there is a rule, specific rule. We can directly find the 20th term. In most of the cases, there will be few cases where this may not be possible. But anyway, so this is what a sequence is. Now there are 3 basic types of sequences or progressions. Okay, so the first of them is an arithmetic progression. Now what exactly is an arithmetic progression? Now arithmetic progression is any set of terms where every successive term is obtained by adding a constant number to the previous term, right? So suppose I have a term A, my first term. I will be adding a term D to it. Now I will be adding another term D to the second term, right? So I will get A plus 2D. Similarly, A plus 3D. This is one full term, right? Remember, this is the first term, second term, third term, fourth term. So how exactly can we write or produce the nth term? I write that as Tn, T for term, N for n. So nth term is given by A plus n minus 1 into D. Now there are some specific names for these all these letters here. So A stands for the first term, obviously. D is the constant difference or the common difference, and n here is this is transient here. You change n, you will get a different term, right? So this is how you obtain Cn. Now finding the sum of the first n terms actually is just very simple from here. You can just write them in the first in the proper increasing order of terms A1, A2, A3, like A plus B, A plus 2D, or you can then you can write them in the reverse order. A plus n minus 1D, then A plus n minus 2D, and finally add them up, and so you will get this well-known formula. For the sum of the first n terms, which can also be written as n by 2 into A plus L, where L is just indicative of the nth term or the last term. Here, since there is n, we can also write L is equal to En. L is nothing but the nth term actually. Here, L just stands for last term. Okay. Now, since an arithmetic progression involves only addition, and yes, subtraction is also there when we have to find out the common difference. Since this is the case here, so if we have say 2 arithmetic progressions, first one has terms A1, A2, A3 like this, and here the common difference, let that be equal to D1. Similarly, if you have B1, the second series, suppose B1, B2, B3, and here the common difference was D2. Now if you add these 2 series, now what do you get? You get A1 plus B1. You have the second term is A2 plus B2. Similarly, the third is A3 plus B3. Now if you observe, when you subtract now the second term, first term from the second term, you get A2 minus A1 as B1 and B2 minus B1 as B2. So the common difference is actually d1 plus d2. Actually this is again a constancy which proves that when two arithmetic progressions are added, their common differences add up and they still become or they still remain an arithmetic progression, right? So the common difference here was d1 plus d2. Okay. Now once I am done with this, what exactly is an arithmetic mean? This is a very important concept. Okay. Now suppose there are three. Let's start with A, B, and C. Suppose these three are in AP. So what we can write is, we can write that B minus A, which is equal to D, right, is equal to C minus A. Here D is the common difference. Don't think that this is the fourth term or something. D is just the common difference, right? So we have C minus B here. C minus B, right? The common difference is constant, so we can always write this equation. Now what do we get from this? We get that 2B is equal to A plus C, or in other words, B is equal to A plus C by 2. And this is called the arithmetic mean. This is the arithmetic mean of A and C, right? B is the arithmetic mean of A and C. So generally we can write this as the arithmetic mean. Arithmetic mean is usually written as A, and suppose we have the terms A1 and A2, then arithmetic mean is given by A1 plus A2 by 2. Now, that's a very rare case that we have only two terms, and in this case, this doesn't actually make much sense. That doesn't give you any insight about the series. So, let's generalize this for an n-term progression, in which case A is given by sigma ai over I by n. Let's suppose there are n terms. Sigma ai is nothing but the summation, so it's nothing but a1 plus a2, like this till an by n. Suppose there are n terms, so you just add the n terms, you divide it by the number of terms, that is n. So this is how you obtain the arithmetic mean, right? Okay. So now there are usually cases or situations where you are supposed to insert a fixed number of arithmetic means between two numbers, right? So how do we do that kind of how to deal with that kind of situation? Okay, suppose we have terms A and B, right? And you're supposed to insert n arithmetic means between them, right? This is no haphazard manner of inserting terms between them. You're supposed to put a definite order of arithmetic means between them. So let us call them A1, A2, all the way an minus 1 and an, right? So let there be this term, rth term, any general term of these arithmetic means. So how exactly do you find out these arithmetic means now? Now it's a very simple thing. We know that there are total n plus 2 terms, right? You have one here, and there are n terms introduced. So there are n plus 2 terms. Let the common difference between A and B. Okay, now after that, it just becomes, suppose you are supposed to find out A1. A1 is A plus the common difference divided by the total one, right? B can be written as A plus n plus 2 minus 1, which is n plus 1, right? Into, let's say the common difference is D. So D is nothing but B minus A by n plus 1. So we get A1 is equal to B minus 1 by n plus 1, right? Because A1 is just A plus D. Similarly, A2 you get into 2 times of B minus 1 by n plus 1. So we can write the general form as AR is equal to, for any general term in this, so we can write AR is equal to A plus R times B minus A by n plus 1. Note that we know A, we know B, we are supposed to find it for AR, so we know R, we know obviously know the N, so we can easily find out from this equation, right? Okay. So let's now move to a geometric progression. Another very commonly observed progression in nature. Okay. So a geometric progression is any set of terms where the successive terms are obtained by multiplying a constant number, a fixed number, right? So suppose I start with A again. A will represent my first number, or first term. The second is given by AD. Third is given, it's not D. We usually denote this by R. So AR squared, and like this, the series goes on, right? So since so how do we exactly write the nth one? Pn is given by A R power n minus 1. Note that there was, in arithmetic progression, there was n minus 1 into D. Here we have R power n minus 1. So n minus 1 is always there. Obviously, because you start adding the common difference or introducing the constant multiplication term in the second term only. So you should get A R power n minus 1. Right? Now, again, the sum of this is a very standard result and is easily obtained. I'll just write the formula. It is A R power n minus 1 by R minus 1. Now, there are some different ways. Unlike arithmetic progression, you have different cases here. You may, if you are not careful, you may actually get it wrong. So these are the cases where this though is correct, but you should be careful. This is actually for R greater than 1. Actually, this can be used for all cases. But suppose R is equal to 0. So let us analyze. We have A into R 1 power n, that is 1, minus 1, that is 0. And denominator we have 1 minus 1, again 0. So you have of the format A into 0 by 0. This is an indeterminate form, right? You don't know what this is. But if you just observe the series, you know that this is A, then A, like this, there are n terms. So what should the sum is nothing but NA, right? So just be careful in such a situation. Okay. Now when R is less than 1, you may argue that the denominator is R minus 1, which is less than 1, less than 0, this is a negative number, right? So there may seem to be some kind of confusion here. But note that the numerator is again R power n. Now since for any number R power any number less than 1, less than 1 here denotes between minus 1 to 1, right? Let's just take the absolute value. So if that is less than 1, if it is between 0 and 1, R power n also will be between 0 and 1, and hence the numerator also will be negative, in which case you will get a positive sum, right? So there is no inconsistency here, but yes, you can write it for your own clarification or just so that you don't get confused. So you can write this here. I have just written R as the absolute values. Okay, I didn't specifically write them, but for negative ones also you can just take it that way, right? Okay. So this is how you write the sum of a geometric progression. Now, some very basic things. We said the second term, that is second term by the first term, which is nothing but AR by R, right? So R. And third term by second term is also the same thing, right? Now note that suppose I take the logarithm of all these terms of a geometric progression, what do I get? Log A1, log A2, like this, right? Now let us take the common difference. So you get, let us just take the difference, successive differences. What is this? Log of A2 by A1, right? But what is log of A2 by A1? This is equal to log R, right? Similarly, log A3 minus log A2 is again log of A3 by A2, which is again log R, right? So we see that the difference between the successive terms is a constant, because R is a constant here, and the difference is log R. Hence, if there is a geometric progression, the logarithm of the individual terms of the geometric progression will yield an AP, an arithmetic progression, right? Please note that this is the converse of this is also true. If you have any number of if you have some logarithm, if the logarithm of some terms are in AP, then those terms will be in a geometric progression, right? Let us now find out the geometric mean. This concept is taken straight from the arithmetic mean and is noted by G, right? So suppose there are two terms A and B, right? So let G be the geometric mean between them, that is G lies between them. So G by A is also equal to B by G, right? Or cross multiplying, we get that G square is equal to AB. Or you can take the square root and find out that G is equal to root of A into B, right? So this is how geometric mean is defined. But then again, generalizing it for a lot of terms, say n terms, we get geometric mean is equal to A1 into A2 into A3 into A4, like this till An into 1 power n, right? So G power n will be nothing but A1 into A2 into A3, like this till An, and you take the square, you take the nth root of that, and you get the geometric mean for all these numbers. Okay. Now suppose you insert again a fixed number of geometric means between say two numbers A and B. How do you find out those numbers? So let this be G1, G2, like this is Gn, and the last term is B, right? So we are inserting these n geometric means between A and B. Okay. So how do you write these terms now? Now you know that there are again n plus 2 terms here, right? And B can be written as A. Let the constant ratio or the common ratio be R, and this is nothing but n plus 2 minus 1, right? We have n minus 1 as the exponent. Here it will be n plus 2 minus 1, which gives us n plus 1. So from this you can get R is equal to B by A raised to 1 by n plus 1, or n plus 1th root of B by A, right? So now you can write the GR as A times B by A power R. So the constant ratio of power. Yeah. Okay. So let us not write GR. We just confusing terms here. Let's write this as GK. Right? So K by n plus 1. Notice this will not be K minus 1, this will be K itself, because G1 is the second term, right? G2 is the third term. GK is actually K plus 1 term. So K plus 1 minus 1 gives you K, and then you have the ratio as B by A power 1 by n plus 1, right? So this is how you can insert a fixed number of geometric means between two numbers. Now let us see what a harmonic progression is, right? Harmonic progression is actually a bit confusing, plus a bit unusual, and you will not be getting a lot of say sum and all. You cannot easily you cannot find them out. Let us see why. Okay, so if there is an arithmetic progression and you take the inverse of the multiplicative inverse of all those individual terms, then what you obtain is called an arithmetic harmonic progression, right? So suppose A1, A2, A3 all are in AP, right? Suppose I write 1 by A1, 1 by A2, 1 by A3. These are in harmonic progression. So we actually define it the other way. We say, so we actually write them the other way. We say A1, A2, A3 are in HP if 1 by A1, 1 by A2 and 1 by A3, all these terms are in AP, right? So this is just for explanation. It's usually written in the other way. HP here. right? Now, since we have the second series in arithmetic progression, we can easily find out the common difference, right? Since they're in AP, we can easily define what the common difference is, and we can also find out a formula for them, right? So similarly, so using that, we can say write the nth term of a harmonic progression, and this is how it is written: an is equal to 1 by a. Right. So if you note carefully, what I've written in the here in the denominator, these are new terms, right? We didn't define what a is, we didn't define what d is. So a is nothing but 1 by a1, and d is nothing but 1 by a2 minus 1 by a1. Right? So a can be written as 1 by the whole thing, right? 1a plus n minus 1 into d. Okay. So there is no specific formula for the sum of n terms in a harmonic progression. Given a short harmonic progression, you may have to find it out using basic calculation. There may not be any formula for that. Right. Now for a harmonic mean, how do you find out the harmonic mean? Again, the concept is same. Suppose a1 and a2 or a and b are two terms in a harmonic progression, and suppose you introduce a harmonic mean between them. Let that be denoted by h. Okay, h. Now h is written as 2ab by a plus b. Now, this is a simplified version. Actually, it's pretty simple. You know that a, h and b will be are in harmonic progression if 1 by a, 1 by h, 1 by b. These three are in arithmetic progression, right? So you can always write this way: 1 by h by minus 1 by a is equal to 1 by b minus 1 by h, right? Successive terms have the same difference. So taking h to 1 by h to the other side, 1 by a to the other side, and then just simplifying, we get h is equal to 2ab by a plus b. Similarly, we can define it for n terms of a harmonic progression. Again, it's just this way: 1 by h is equal to 1 by n into 1 by a1 plus 1 by a2 till 1 by an, right? So all the terms written in the multiplicity inverses, add them up, divide that by n, and then that is nothing but the inverse of the harmonic progression, harmonic mean, right? Remember that this is 1 by h here, not just h, right? Okay. Now we move to a very important and slightly confusing progression. This is called the arithmetic geometric progression, right? So the name is I'm sorry. So what if or how do we insert arithmetic harmonic means between a and b? Right? Again, the concept is exactly same. H n and the last term is b. So again, you use the exactly same we use exactly the same okay. So let us now introduce n harmonic means between a and b, right? So suppose a is the first term, and now these are again the same introduction of again n harmonic means instead of arithmetic or geometric means as we did in the earlier case. Now we are supposed to do the exactly same thing, and you get this as the formula: 1 by hr, where again r is the r plus 1 term or the r harmonic mean, 1 by a plus r times a minus b by n plus 1 into ab. right? So again, just follow the same procedure as in earlier cases, and you should get back this formula. Okay. Let us now move to a very important progression called the arithmetico-geometric progression. So what exactly is an arithmetico-geometric progression? Any series of the form AB, look closely at the terms here, a plus d into br, a plus 2d into br square. Okay, so any term of this form, any series of this form is called an arithmetico-geometric progression. Now, why exactly is it called that way? Look closely. A is transformed as an arithmetic progression, right? A plus b, a plus 2d, a plus 3d. Whereas b, the second part of the first term, is actually transformed as a geometric progression. B, br, br square, right? So, initially it may look tough, but this actually gives us a way to find out the general form for finding the sum of any series, right? So, how do you do this? Okay, so let S be the term. Let S be the sum of the first n term. So this AD, A plus D, BR. Okay, like this. Now what I do is I multiply all of this, or the whole equation with an R, right? The same constant term. And what do I get? I get ABR plus A plus D into BR square plus A plus 2D into BR cube, right? And now I shift all of them. I mean, while writing this, I just shift all of them in one place. So I write this as ABR, A plus D into BR square, similarly A plus 2D into BR cube, right? Now you note that suppose there was plus, suppose there was plus Tn here, instead of here, I'll have plus Tn in the next place, right? I'll have Tn minus 1 here, and then I have Tn in the next one, right? Now I subtract them, so I get Sn into 1 minus R. The first term is as it is, and now subtract the terms in those respective columns, right? So A plus D into BR minus ABR gives you DBR. Similarly, A plus 2D into minus A plus D into BR square again gives you DBR squared. Like this, and the last term does not get cancelled, right? You have the, okay, by the way, it's Tn into R, right? So the last term actually here is Tn into, instead of this Tn, it should be Tn into R. Right, so RTN. Now we know the formula for RTN, and now you see that all these terms still here, all of them are in actually a geometric progression with the first term as dB and the common first term as dBr and the common ratio as R. Right? Don't get confused. The first term is actually dBr. Okay, and then you have another term AB here. So adding all this and then dividing the whole thing by 1 minus R here, you get the formula for Sn. That actually will not give you much. You have to do a few other things which we will be covering in the next slides. Okay, so but there is one specific case. If the R here is the absolute value of R is between 0 and 1. Okay, 0 doesn't make any sense. Again, 1 just makes it a trivial thing. So if the value is between 0 and 1, you get this result which is sometimes used. Right? R is less than 1. Here obviously by R I mean the absolute value of R. Okay. Okay, now let us look at some of the most important results. These results again, because there are progressions, we just obtain these results, and some of the most important of them are these sigma I, right? I obviously goes from 1 to n, all of them being integer natural numbers here. This is nothing but 1 plus 2 plus 3 till n. Right? This is given by n into n plus 1 by 2. Similarly, sigma of I squared, again I from 1 to n, it means 1 squared plus 2 squared plus 3 squared till n squared is given by n into n plus 1 into 2n plus 1 by 6. Oh sorry, it's not r here, it's cube. Right? So, this is actually, this one may confuse you sometimes. Note that sigma of the cubes of first n numbers, right? So 1 cube plus 2 cube till n cube is nothing but the square of the sum of first n numbers, right? N into n plus 1 by 2 whole squared is n squared into n plus 1 whole squared by 4, which is what we get here. Okay, but there may not be exact relation between them. Just know that these are the formulae. Again, there are two other formulae which are again used sometimes. Right? So this is just 1 minus x power minus 1. Power minus 1 is nothing but 1 divided by 1 minus x. This can be written as 1 plus x squared till infinity. The only constraint here is x should lie between 1 and minus 1 and 1. Right? Similarly, taking it for the second one, just squaring this, you actually get this interesting result. It's not, you may have expected something else, but you just get this as this as a thing. You get 1 plus 2x plus 3x squared plus 4x cubed plus 5x power 4, like this, again till infinity. Again the same condition remains. Right. Now let us look at one of the most important methods of calculating the sum of a series, which is known as the method of differences. The method of differences is actually the exactly same thing which we used for finding the sum of an arithmetic or geometric progression in the previous slides. Now again you just write both of them, you just shift write the series one below another, and you shift the terms in the second one and then just subtract them. So you get actually a form for the nth term, which you can now write in terms of, right, I'll just show it quickly, a1 plus a2 till an. Now what I do is I write a1 here, I write a2 here, so I write an minus 1 here and an here. I just subtract both of them, I get 0 plus a1 plus a2 minus a1, so this is just minus. Similarly you get all this till an minus 1, now minus an, right? So you can now express a in terms of all these things. Say a2 minus a1 is, these are again, suppose geometric progression, arithmetic progression, so you have a2 minus a1 as d, similarly a minus an minus 1 as d, and you get that some terms d here. Now once you express an in terms of these numbers, you can use these results now to find the sum of such a series. We will be taking these up extensively in the questions later. So that is for them. Now a few more inequalities. These are some of the most powerful and useful inequalities in all of mathematics. They state that A, right. So what does this mean? A, G and H stand for our well-known arithmetic, geometric and harmonic means of the same series. Mind you, they must be the same series, otherwise it doesn't make any sense. Right. Now, arithmetic mean is always greater than the geometric mean, and that is again always greater than the harmonic mean. The inequality is a trivial case when all of the numbers are nothing but the same number. Right. So if you have A, right. So they are if all the numbers are nothing but A, then they are in arithmetic progression, they are in harmonic progression, they are in geometric progression, and their arithmetic, geometric and harmonic means will also be the same thing and which will be equal. So that is the only case, otherwise they always follow the strictly greater than sign. Right. Apart from this, there is something called as weighted means. Right. So I just denote this is the weighted arithmetic mean. A stands for the arithmetic mean. The asterisk above stands for the weighted mean. Right. So this is nothing but sigma mi ai by sigma mi. So mi, let mi be the weight of every term here. So this is actually the meaning. This formula can also be seen in statistics, right? When you find out the mean of any data, so what you do is, suppose 10 occurs 4 times, you multiply 10 4 times, and similarly suppose 5 occurs twice, you multiply 5 with 2, right? Suppose this is a part of a data, then this is how you find out the arithmetic mean, right? You don't take out you just don't take a1 plus a2 plus a3. You multiply the similarly occurring numbers with their weights, right? Similarly, the harmonic mean is defined as sigma mi by sigma of mi by ai, right? So this is sigma of mi by ai, that is m1 plus a1, so m1 by a1 plus m2 by a2 plus m3 by a3, and the numerator is just m1 plus m2 plus m3, right? And the geometric mean is right. So the geometric mean, weighted geometric mean is nothing but a1 power m1 into a2 power m2 into a3 power m3, like this. The whole thing multiplied, then raised to the power 1 by sigma of mi. So it's 1 by, instead of our familiar 1 by n or 1 by n plus 1, something like that. No, we don't have that. We now have 1 by m1 plus m2 plus m3, the sum of the weights. Right. So that concludes the important formulae and important formula concepts regarding progression series. Stay tuned for questions. Thank you.